video is going to cover electron configurations and orbital diagrams. I would highly suggest you get some extra scrapbook paper to take a few extra notes on. Okay, so what is an electron configuration? Well, it's a description of where the electrons are actually located within the atom. And each element has its own configuration. Okay, so we've been talking about valence electrons being the outermost electrons. And because of the outermost electrons, they are going to be the highest energy. So they have the highest N. So here are your rules for arranging electrons. There's 3 of them, and you're going to be expected to be able to cite them and write them down because they're necessary for doing these. So you have the Aufbau principle. This states that electrons are placed in orbitals with the lowest energy first. So we always fill S, and then we'll fill P, and then we'll fill D, and if we're all the way down there, then we'll fill S. That's the order that you're going to go with, S, P, D, F, from lowest energy to highest. And the Pauli exclusion principle states that an orbital can only have 2 electrons. We already covered that when we did quantum numbers. And then Hund's rule, only 1 electron will enter each orbital separately with the same spin until all the orbitals have paired up. So if we take our P is going to have 3 orbitals. And each electron is going to enter with the same spin. So this one's going to go here. The next one will fill in the next orbital. And then the next orbital will be the same spin. Now once all 3 orbitals are filled with 1 electron spinning the same direction, that's when we'll add the electrons that are spinning in the opposite direction. And that's how we told you each element's got its own configuration. So I'm going to go through the first few lines so you can kind of see how this works. So we start with hydrogen up here. That's a 1s1. We come up here, that's 1s2. So each of those orbitals, that's the 2 electrons that are in there. We come down to the second period, so we put a 2 in front of our orbitals now. So we have 2s1, so this one becomes 2s2. We come over here to the p orbitals. We have 2p1, so this will be 2p2, 2p3, 2p4, 2p5. We'll come back over here, it's 3s1, 3s2, 3p1, 3p2, see this is kind of simple, 3p3, and so on, 3p6. So you can see how the p's orbitals have 6 electrons. So this says 1, 2, 3, 4, 5, and 6. Whereas the s orbitals only have 2 electrons. We have s1 and s2. I keep on going down here, 4s1, oops, 4s1 and 4s2. Now here's where the change comes. These d orbitals, this row is actually still part of the 3rd sublevel. So this is 3d1, 3d2, 3d3, 3d4, and 5, and 6. And that shows you that our d levels have 10 electrons. And then it continues on with 4p1, 4p2, 4p3. Okay, let's go through the orbital diagram for potassium. So we can see potassium is at the 4s1 mark on your graph. So let's fill in our orbitals from lowest energy to highest energy all the way up to 4s1. And here's a good picture that will help you to help you if you get stuck with where is really the next highest orbital. So let's start with 1s1. Here we go. And 1s2 is going to have the different spin. Then we can go to 2s. So this is 1s. This is 2s. So this is 2s1. This will be 2s2. Now we can go on to 2p. This will be 2p. 2p1, 2p2, 2p3. Then we come back and go 2p4, 2p5, 2p6. Okay, the next one, we're going to go to 3s. So this will be 3s right here. This will be 3s1 and 3s2. Then we go to 3p. This will be 3p. It'll be 3p1, 3p2, 3p3. Make sure you do it like that. Then 3p4, 3p5, 3p6. Then you go on into 3d. So this over here is 3d. It's 3d1, 3d2, 3d3, 3d4, 3d5, and then come back and finish it out. And then finally, we end up at our 4s over here. And potassium is only 4s1, so that's where we put it right there. And that'll be our valence electron. Okay, now let's run through some examples. Let's go through the electron configuration for argon. You see argon's in the 3rd period, it's a noble gas. So you go 1s2, 2s2, 2p6, That puts you at neon. You come back and you go 3s2, 3p6, and there you are, argon. So the orbital diagram would go, this is 1s, this is 1s1, this is 1s2. Then you can come up and go 2s. This is 2s1, this is 2s2. 2p. You go 2p1, 2p2, then you go over here to 3s. Go 3s1, 3s2, and 3. This is 3p. This is 3p1, 2, 3, 4, 5, 6. So there you go. And if you keep in mind, argon is a group 18 element. It should be an 8. Group 18 element. So it's going to have 8 valence electrons. We have 6 valence electrons here in P, and the other 2 over here in S. So those are your valence electrons. Switch sublevel of the electrons in. We're going to just call it P. How many valence electrons does argon have? 8. Okay, the electrons with the highest energy level are in what? It's going to be 2p. Okay, so pause this. We'll practice it and see how far you can get. Okay, I went ahead and skipped this example for you. You can write down the electron configuration for carbon yourself. But you are going to be given the configuration and asked to determine which element it is. You can go through each element and figure it out, or you can take a shortcut and just look at the last one. 4d7. So you go down to 4d, which is actually on period 5, and just count over 7 elements within your transition metals. That's 1, 2, 3, 4, 5, 6, 7. That's RH. So go ahead and keep practicing. Now we can take those electron configurations, we can actually abbreviate them, which is going to save you a lot of time. So to write abbreviated configurations, you look at the noble gas in the previous period, and you place brackets around the symbol to indicate the element has the same configuration of that gas, and then you just fill in the last period of whatever follows. So let's see what this looks like. Configuration for iron is that. It comes all the way to 3d6. But if you look at the iron, it's in period 4, so you go up a period and you find the noble gas. So noble gas in period 3 is argon. And then you bracket in argon to indicate it has that same configuration up to that point. Then you just fill in the rest, which would be followed by 4s2 and 3d6.
Who's the only one here who knows the illegal ninja moves from the government?